So good evening everyone. Now last week we completed fourth lesson, that is Newton's laws of motion, and today we start the fifth lesson. Right? Today we're going to start the fifth lesson, and fifth lesson also physics. So that is friction. So friction also actually it's a type of force, frictional force. So due to friction, there are advantages as well as disadvantages of friction. We'll be discussing that in detail under the last part of this lesson. But let's see what is friction first. So it's a type of force, and it is a vector. It has a definite direction. And if you are trying to move an object, any object on a certain surface, so there's a resistance from the surface, or else the frictional force actually it is acting against the motion of an object. It opposes the motion of an object. So that disturbance, so that barrier to move an object is that is a frictional force. So frictional force can exist even in the motion of liquid and gases also. Imagine, so when you are swimming, there will be a friction from water. Or when you are flying kite, or maybe a rocket or helicopter or plane, so there's a resistance from air, that is also friction. So frictional force can exist in motion of liquid, gases and solid, all three. But here we are discussing only the frictional force that act between solid bodies. Between liquids friction can act, liquid and solid also friction can act, solid and gas also friction can act. Example, you might have learned about this. Now when a meteorite or celestial object enters earth atmosphere, it get catch fire. Meteorite because of the friction between air and the gas particles and the solid object. Therefore it is always acting against the motion of an object. Sometimes due to the friction it can cause wildfires. So example, we got in Lamborghini. Between the when you are rubbing your palm also, what happened in cold climate, so it's getting heated up. Or many machines, engines getting heated up due to the friction. When two solid parts rubbing each other, heat is generated. Even ancient time, the Stone Age, the ancient people, they found fire also by rubbing two stones against each other. Even you can see the matchstick. So example, we rub against I think I have mentioned about that under grade 10 PowerPoint slide also about this. I'll share that with you. Grade 10 PowerPoints under the third lesson about this metal, non-metal and metalloids. So you can see the screen away. When you are going to light up the matchstick, you have to rub that against the other one side of the box. Let me show you that. So friends, the best example is this. So this matchstick, you are rubbing that against the matchbox, right? So this matchstick you are rub against the matchbox. So what happened now? When you rub this against the matchbox, there will be a friction. Due to friction, so this is the matchbox. So when you are rubbing this against the matchbox, so this is the dark air, so this is contain chemicals this side. So when you are rubbing this against the it get catch fire. That is due to the friction. That is due to the friction between the match head and the side of the box. So friction caused the fire here. Friction between what? Between the head of the matchstick and that contain chemicals, sulfur, and the box of matches contain phosphorus. So then due to the friction, the surface is getting heated up, and the matchstick or the head the match head gets catch fire. So this also actually do. Sometimes what happen in cold climate due to moisture. So if it is not, friction is not enough, you have to use several matchsticks, right? And it takes long time. I mean, then you have to heat it. Like if it is if this absorb moisture, the matchbox, so then it will difficult to get that friction, because the moist surface, it takes long time to do it, to finish the job. Right, then next one, I'll erase the screen. So this is actually, these things not given in your textbook, but you can see now these are the applications of friction in our day-to-day life. Friction, sometimes what happen, friction is a disadvantage, that's why streamlined body shape. So the ships and the boats and even the rocket, streamlined body shape. You have done this, you have heard about the streamlined body shape. In Sinhala we call it anakula hadaya. That also reduces the friction, air resistance and friction by water. Most of the aquatic animals, they have this. That is to reduce the air resistance and resistance by water. So this is the streamlined shape, streamlined body shape, that reduces the friction between the between water and the body of the animal. Or maybe when you are setting the rocket upwards, so to reduce the friction by air. So they have the front end, we have the streamlined shape. Right. So there are many examples for this. Okay. So this is like introduction to the lesson. Okay, let's move back to the theory tube. Now let's see, there are okay, first one, look at the screen now. Can everyone see the screen? Okay. Frictional force. So the force which opposes, they will never ask the definition of what is known as friction in the exam, but you should know the meaning of this word. Which opposes the relative motion between two bodies. I'll highlight this word, opposes, so act against, opposes the relative motion between two surfaces. It opposes, it acts against, a force that acts against the motion of two surfaces, relative motion of two surfaces when they are in contact. It is known as frictional force. That means prevent the motion of an object on a surface. It is a property that prevents the motion of an object. Prevents the motion of an object. So imagine now, I'll give one more example. Sometime when you are going to buy tiles, so the bathrooms we use matte tile, rough surface. The tile surface rough. Otherwise, you will easily slip inside the bathroom, wet surface, right? And if you take the dining or your living area, sometimes we use gloss, right? Tile, glossy surface. And or verandas, and also sometimes we select matte tiles, matte surface, so the rough surface, different roughness. So again, friction matters there. Friction matters there. In addition to that, when playing carom, there's a friction resistance between the carom board and whatever moving on the carom board. So to reduce that friction, we use talc powder. That is to reduce friction. Sometimes we want to increase the friction, sometimes we want to reduce the friction. It depends on the situation. In some instances, to prevent the slipping, we need to increase the friction. Example, the tires of the wheels of vehicles, vehicle tires having rough surface. When the tires are worn out, it's risky to drive fast on rainy days. When the tires are worn out, it is very risky to drive fast on rainy days, because when you apply brakes, the vehicle might slip and might go out of the road sometimes. So it's very difficult to apply brakes and stop the vehicle when the friction is low. Low friction means it's easy to slip. High friction means it prevents the slipping or the motion. Therefore, friction, there are advantages as well as disadvantages. Friction is always act against the motion of an object. Okay, so that is about the meaning of this word. If you only write friction is a force and it is measured in Newton also, if you only can put a stand right here, friction is a force, friction is a type of force, and it is measured in Newton. Friction is a force and it is a vector, and it is a vector. It is a vector quantity. VECTOR, vector quantity. Plus unit T equal unit of measure in friction. Unit of friction will be Newton. That also you better write here. Unit of friction will be Newton, capital N, Newton. Please note down these things. Right. Then next one I have given, when an object resting on a surface, imagine on a horizontal surface, underline the word here, horizontal surface, resting, underline, on a horizontal surface, there's no friction acting on it, there's no friction acting on it, no friction acting on the body. But if someone is trying to pull or push the object, then the friction will be acting on that. When an object resting on a horizontal, that means no one, imagine there's an object or book or something, brick on the table on a flat surface, horizontal surface. So no one is pulling this and no one is pushing this. Right? No one is pulling and no one is pushing. This is just resting on the surface. Rest on flat surface or horizontal surface. Horizontal surface. It is just resting. Then what? No friction acting on it. No friction. Because it's not going to move. No friction. But if you are trying to pull this, then friction is acting against the direction of the motion. Friction between what? Between the surface of the table and the object. So this is the friction. So this end you are pulling. This end you make a pull. You pull this. So then this is the object. And here the surface. Horizontal surface. So therefore there are two forces acting here. One force is what? Pulling force forward and frictional force backwards. If these two are balanced, object will be at rest. If these two are balanced, object will be at, imagine you pull with 10 Newton force. If pulling force 10 Newton and friction also 10 Newton, then what happened? Forces are balanced according to the Newton's law, first law. Until you make this unbalanced, object is at rest. Therefore, just because of applying a force, you can't tell the object is moving. Just because of applying a force, object is not moving. So when you apply a force, so if you are going to pull the cupboard, or if you are going to pull the table, or if you are going to push the vehicle, so between the tires of the vehicle and the road, or between the legs of the table and the floor, there's a friction acting opposite to the direction of the motion of the table. Between two surfaces, there must be a relative motion. Either you are going to pull this, or either you are going to push this, or if that tends to move, then the friction exerts. Right? If it is just resting on a table, on a horizontal table, no one is pulling, no one is pushing, then no friction. That's also very important. That's what I have given in this diagram. Right? Okay, so if you only can copy it on this diagram also, now I'll erase this. Latecomers, if you miss anything, you can request the recording. Okay, I'll erase the screen now. Then let's see this diagram. So I told when an object is resting on horizontal surface, I told there's no friction acting on it. There's no frictional force acting on it. So this is the diagram I have given here. So here no one is pulling, no one is pushing, but there are forces acting. Even though no one is pulling, no one is pushing this, but there are two forces acting on this. What is W here? Weight of the object. What is W here? Weight of the object. Weight of the object. W is the weight of the object. And R is what? Perpendicular reaction. What is R here? Perpendicular reaction. Perpendicular reaction. That is R. So these two are equal. Therefore, forces are balanced. So when it is, so this is resting, at rest. This is at rest. Therefore, why it is at rest? These two forces are balanced. Even there are forces act. Even imagine now you are sitting on a chair. Sometimes you might think you might tell no one is pulling from my hand or no one is pushing me. Actually, there are two forces acting even now on your body. One is the gravitational pull. That is your weight. Weight is due to the gravitational force. So here W will be the weight. That is measured in Newton. If it is, imagine here 1 kilogram object. If it is 1 kilogram object, 1 kilogram, what is the weight? 10 Newton. How to convert 1 kilogram into 10 Newton? I gave the equation the previous lesson under Newton's laws. W equals mg. So then the reaction also will be what? Upwards. That also will be 10 Newton. Reaction also will be how many Newton? 10 Newton. 10 Newton. So these two are balanced. Then it get cancelled. So what is the unbalanced force will be 0 here. Therefore the object is at 0. If you write here unbalanced force will be 0. Because forces are balanced. Unbalanced force will be 0 or resultant force will be 0. Resultant force will be 0. Therefore the object is at rest. No friction acting on it. No friction acting on it. Therefore when an object or block of wood resting on a horizontal surface, frictional, because it's not going to move forward or backward or upward or downward. But there are two forces acting due to the weight downwards, that is action. It's like the Newton's third law. Action is downwards, the weight, and the reaction is upwards. Those two are balanced. They are equal. Therefore, they get cancelled. Therefore, the object is at rest. That is figure 1.1. So, be careful. The first diagram and the second diagram. So, this is horizontal surface. Then next one I have an inclined plane. You can see the diagram now. I think you can see the next diagram. Inclined plane. Anata thalaya. In single we call it Anata thalaya. Anata thalaya. So inclined plane. So this surface you incline now like this. What will happen now? Now the object tends to move. The same block of wood, the surface you make an inclined plane like this. Now what happened? These two also there. Weight and perpendicular reaction, those two also there. But in addition to that, now it tends to move down. It tends to move down. Then the friction acts against that and prevent it from motion. Prevents it from motion. So example, sliding boat. Sliding boat. Anyway, the downward force must be greater than the upward, the frictional force in order to slide down. So there, this pink one will be the friction here. Friction between what? Surface and the object. And the black arrow, the forward, that is the due to the weight or the gravitational force, the force acting downwards. Sometimes if you want, you can pull this also. So when an object resting on an inclined plane, right, frictional force acting on it. Frictional force, complete the blank here, frictional force acting on it. Frictional force acting on it. Here no frictional force. Here frictional force is acting on it. Again I am repeating, when an object rests on a flat surface, horizontal surface, no friction acting on it. Because no one is pulling, no one is. And when you incline the surface, then the friction is acting upwards, so against the motion of the object. So here, if the object is not moving, right, object is not moving down along the plane due to the, again, frictional force. Frictional force. Right. So that's the answer for the first three blanks. And label the diagram also, you can label and mark the forces. So that is 10 Newton, just to have an idea, because how to convert kilogram into Newton? W equals M mg. We discussed that last week. W equals mg. W equals mg. W is equal to mg. What is m here? 1 kilogram. G is 10 ms minus 2. Gravitational acceleration of the earth is 10. Exactly 9.8, but calculation we use the approximate value 10. So this will be 10 kg ms minus 2, that is also equal to 10 Newton. So remember, Newton is also equal to kg ms minus 2. Kg ms minus 2. That's how you convert kilogram into Newton. What is the equation we use to convert mass into weight? W equals mg. Right. Anyone still copy down? Please raise the hand. Did you all finish writing? If anyone of you are still writing, please raise the hand, or else I'll erase the screen now. Next diagram. Okay, I'll erase the screen. Next one you can see. This is the inclined plane. What is this? Inclined plane. Inclined plane. Now what happened? Due to gravitational force, there's a force acting downwards. So that's what I explained before. And between the object and the surface, there's a friction acting downwards. So if the object is at rest, frictional force is equal to the gravity. Here the friction is exerted. Or if there are two instances. So here also, this is number one, the friction, inclined plane. Or if you are going to pull this, then also the friction will exert backward. So please label here, the red arrow is friction, and the forward you attach this to a Newton balance and pull. You attach this to a Newton balance and pull. I'll highlight those two. Friction backwards between the surface and the object, and the pulling force forward. If you want, you can find the force applied using the Newton balance. So this one, can you please label Newton balance? Newton's balance. What is the use of the Newton balance? To find the force applied. Newton's balance is used to find the force applied. Right here, if your Newton's balance is used, or sometimes you call it spring balance, Newton balance is used to find the force applied. Find the force applied. Right. Then the friction also will be the same. So what is W here? How many forces are acting now? There are 4 forces acting. Number 1, weight. Number 2, perpendicular reaction. Number 3, pulling force. Number 4, frictional force. If you want to write that separately. What are the 4 forces acting here? Weight acting downwards due to the gravity. Upward perpendicular reaction. Third one, the pulling force. Fourth one, frictional force. Is that clear? Right. Then next one. Okay, anyone still copy down? Shall I read this? So this is number 4 is friction. So if you remove the pulling force, what? Friction becomes 0. Then the object will be at rest. Now also object is at rest if the pulling force is equal to the frictional force. If pulling force equal frictional force, then the object will be at rest. Or if you want to write that, if pulling force equal frictional force, if pulling force equal frictional force, if pulling force is equal to frictional force, comma, then the object is at rest. 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 Please write that. That means number 1 is equal to 4. If pulling force is equal to the frictional force, then the object is at rest. In this case, the frictional force is equal. There's a special name. There are 3 types of friction. So in this case, the friction is known as static friction. That's what we're going to discuss next. So if the object is, even though force is applied, even though you are pulling this object, look at number 3 here, diagram, look at my cursor, look at the screen, pulling force, even though you pull this, it is not moving due to the frictional force. That friction is known as what friction? Static frictional force. There are 3 type of friction: static friction, limiting friction, and dynamic frictional force. Again I'll repeat: static friction, limiting friction, and dynamic frictional force. So the first one we are going to discuss static friction. There are 3 types of friction. So static friction means what? Before it's moving, before the object is moving, the force acting against the motion is known as static friction. Until it begins to move, we call it static friction. So you can complete the blank now. What is this? Frictional force acting until the object begins to move. Until the object begins to move. Until it begins to move, the frictional force is acting, called static friction. Highlight the word is static friction. Until it begins to move. That means now it is not moving. You pull it, friction is acting against that. But if you want, you can reduce this friction by applying some oil or grease on the surface. Say example, the door hinges, the gate, you put some lubricants or grease or oil to reduce friction. You can reduce the friction if you want. Otherwise, very difficult, you have to make more effort to open or close the gate or the door, or even the vehicle door of the vehicle. Again what? Frictional force is acting when the object is bigger. Until the object begins to move, the friction acting known as static friction. But no static friction if you are not applying a force on it. If it is just resting without any pull or push, then it is zero friction. But if you are trying to pull it, from the moment or from the time that you apply the force or the pulling force, the friction also acting against the force or against the direction of the force applied or against the motion of the object. Now remember, students, now from you are supposed to complete now we are doing the 5th lesson. So unit 1, unit 2, unit 3, unit 4 we have completed. 1, 2, 3, 4 completed. Unit 5, that's what we are doing now. So your grade 10 first term test you are getting from 1 to 6, chapter from 1 to 6. Grade 10 first term test from unit 1 to 6, right? Now grade 10 second term test until unit 14. Now after completing the 6th lesson, actually the first term work done. But anyway, all these 6 lessons I'll be revising in the paper class. I'm going to start the paper class from next month. Paper class most probably it will be from Saturday from 6 to 8. Saturday from 6 to 8. Saturday evening from 6 to 8 Saturdays. So next in May, 7th of May I'm going to start the paper class. 7th of May paper class, Saturday evening from 6 to 8. So the paper class I'll be revising all 6 lessons again, all the past paper questions, Western Province 3rd term paper questions from each lesson I'll be discussing separately, and we are going to do the unit wise revision as well as provincial papers, oral past papers, the questions relevant to each lesson, and the textbook exercise. Plus I have given unit wise revision also separately at the end of each theory tube, because paper class is very important. Otherwise you will find it difficult to answer the questions in the exam. Sometimes you write the answer but it's not relevant to the question asked, you will not get full marks. And paper class, you don't need to pay the full payment, it's just additional 500 payment. You can join the paper class to the existing payment, right? Just 500 per month for the current students. New students it will be different. For y'all, if you are joining the paper class, just 500 per month. You can join from next month the paper class. So next month when you are going when you are going to make the payment, please make sure if you are joining the paper class, you have to make additional 500 monthly payment. Right. So that's from May, and it's Saturday from 6 to 8. Right. Then next one, you got to keep that time free. Because remember now, grade 10 there are 20 lessons. Now only the government school they are starting the syllabus. I mean the grade 10 work. Right. Now remember, it's a challenge to complete all 20 lessons by December. I know some of the private schools they have already started this last year in September, the international schools, and some of the private schools in January this year. But now government schools started this grade 10 work in April, and that means this month only they started this, right? Therefore it's a challenge to complete this also. But anyway, your oral paper based on grade 10 and 11 syllabus, not from 9, based on 10 and 11 syllabus. Right, so let's move on to the next part. So I explain now what is static frictional force. Even though we apply a force, the object is not moving due to what friction? Static friction. In Sinhala we call it Garshana Balaya. In Sinhala we call it Gatika Garshana Balaya. Sthithika Garshana Balaya, I think. Yeah. But anyway, no need to remember the single term. But anyway, this Garshana, the friction means when you are rubbing your hand against each other, the friction exert and the hands getting warm up. If you are imagine if you are hammering, if you are hammering to a metal sheet with a hammer, then what happens? If you are hammering to a metal sheet with a hammer, frictional force again exert. That means that surface getting heated up. Imagine you get a metal sheet and hammer that to the, you are hammering that. You take a metal sheet and you are hammering to this metal sheet with a hammer. So what happened now? When you are hammering, the surface of the metal sheet get heated up. That is due to the transfer of energy from the hammer. So that potential energy, so we will be discussing that in detail later. Right. Then next one, this diagram, frictional force. I'll erase the screen. Look at this. Now here the object is at rest. Object is at rest. So you make a pull in force. Or you can write pull in force. The force applied forward. So you can get the Newton values can be used to find the reading or to find the force applied. And here backwards what happened? This red one will be the frictional force. So what is it? This is called what friction? Static friction. There are three types of frictional force: static, dynamic, and limited frictional force. Static friction. Static friction. Even though force is applied, I have given here, no need to write separately. Even though a force is applied on the block of wood, it does not move due to what friction? Due to static friction. Complete the blank here. Due to static friction. Due to static friction. It is not moving due to static friction. So frictional force, there are three types. Example, I'll give one of the best example. Imagine you start with, first you apply say 5 Newton. Then what happen? Frictional force also become what? How many Newton? 5 Newton. Get balance. Now you increase this up to, you start with 5 Newton. Then you increase this up to say 8 Newton. What will happen? Frictional, static friction also become 8 Newton. Then the object is at rest. Object is at rest. Then you increase the force applied, pull in force up to say 10 Newton. You gradually increase this up to 10 Newton. Then what happen? Frictional force also become how many Newton? 10 Newton. 10 Newton. or you increase this up to say 15 Newton, then frictional force also increases up to 15 Newton. Like that, there's a limit, this will become balanced. After a certain point, even though you are increasing the pulling force, but friction cannot go beyond the limit. There's a maximum friction, it will keep on increasing like this, it will come to a maximum value. Beyond that, the friction cannot increase, but your force you can increase. This one can be increased continuously, but this one, there's a limit. There's a limit, you can, it's limited here, right? It's limited. Beyond a certain point, it cannot go beyond that value. So it depends on the object and the surface. You can't tell exactly this value, but it depends on the weight of the object and the nature of the surface and everything. So then this is actually what happens, they get balance. So static frictional force, it depends on the force you apply here. Right? When the frictional force when the pulling force increase, the static friction also what? Increases. Can you write that here? Yeah, I have given that. The second statement, second bullet, I have given that. No need to write separately. Look at here. The static frictional force increases. Static frictional force increases with the increase of the force applied. So that's what I give here. You started 5 Newton, friction also become 5 Newton. Opposite, get balance. Forces are balanced. Forces are balanced. Here the forces are balanced. Forces are balanced means what? Frictional force become equal to the pulling force. Balance forces. Forces are balanced. That means object is at, therefore the object is at what? Therefore object is at rest. Object is at rest. This is under Newton's what law? Newton's, until you make these forces unbalanced, it is at rest. Newton's first law. Newton's first law. Newton's first law. Until you make this unbalanced, it is at rest. It is at rest. Object at rest remains stationary until the forces get unbalanced. Is that clear? Right. Then I will complete the next blank. The static frictional force increases with the increase of the force applied on the block of wood. Static frictional force increases with the increase of the force applied on the block of wood. The magnitude of the frictional force applied can be read from what? Magnitude of the force applied. Look at here, magnitude of the force applied you can find easily from what? From the Newton balance. And it is equal to what force? Frictional force. Can be read from the Newton balance. Complete the blank. Newton's balance. And it is equal to what? Static frictional force. And it is equal to static frictional force. Because it's at rest. Ne? If it is not moving, it's not equal. Static frictional force. Or just write static friction. Therefore, static frictional force increases with the pulling force. And there will be a limit that it gets balanced. 10, 10, 15, 15. So beyond a certain value, whatever frictional force cannot go beyond that. Then it will reach to maximum value, the final point. Imagine now this increased frictional force increase up to static friction. I have given here leftmost side of 15 Newton. Imagine this increase up to 20 Newton. Then beyond that it cannot be increased. Beyond that it cannot be increased. Then it called limiting frictional force. That is the second type. That's what we are going to discuss next. Right. Then next one. Next, anyone still copying down? Anyone still copying down? Please raise the hand. Okay. When you are done, please lower your hand. Anyone still copying down? Please raise the hand. When you are done, please lower your hand. Now some of the students we have not joined with the correct name code. Done. Okay. Then next one. I'll erase. So let's we'll move to the next page. Now I told there are three types of friction. What is the first one we finish now? What? Static friction. Number two, limiting frictional force. So how to remember this easily? The static friction until object begins to move. Until the object begins to move, that is static friction. When the object just begins to move, the frictional force reach maximum value. So imagine you increase this up to say earlier I told like say 5 Newton, 5 Newton. Pulling force 5 Newton, frictional force also 5 Newton. Then it's balanced. Object is at rest. So you increase the pulling force up to 10 Newton. Frictional force also reach up to 10 Newton. So object is at rest. Object is at rest. Then you increase the pulling force up to 12 Newton. Frictional force also become 12 Newton at rest. In all these cases, when you increase the pulling force, the frictional force also increases to the same value and the object at rest. Now remember, when you increase the pulling force up to 13 Newton, frictional force also reach 13, and that is the last point these two get balanced. That is the final point, these two get balanced, 13. Now this just begins to move. Just begins to move means what? If you increase more than 13 Newton, 13.1 Newton, it begins to move. Just begins to move. Just begins to move. Right? That is called limiting frictional force. When the object just begins to move, the frictional force is known as limiting frictional force. Until that, I'll highlight this green. Until that, all this what? Static friction. 5 Newton is what? Friction is static friction. 10 Newton is what? Is static friction. 12 Newton is what? Static friction. Okay, for pulling force become frictional force. And the object is at rest. Until it begins to move, static friction, the last point where it begins to move, I mean that is the final one, that friction called the highest value, the maximum friction reach here 13 Newton. This is the maximum friction that the surface can reach. This maximum friction between the object and the surface known as what friction? Limiting frictional force. Beyond this point, friction cannot increase anymore. Beyond this point, friction cannot be increased. Beyond this point, friction cannot be increased. Beyond this point, frictional force cannot be increased. That is the maximum friction. Beyond this point, the frictional force cannot be increased. Therefore, what is called? Limiting frictional force. So what is the limiting frictional force? 13 Newton. That is the last point. That means object begins to move beyond this point. Right. Is that clear? Anyway, any of you all, if you want to listen to this recording again, no problem. You can make a request and you can get the recording and watch this within 5 days, any number of times. Literally, you can do it. Now, you can complete the blank. Shall I erase this? If you only can note down this in your writing book separately with the pencil. So, pulling force 5 Newton forward, frictional force also backward 5 Newton. That is called static friction. Object is at rest. Forces get balanced. Resultant force 0. Anyone still copy down? Please raise the hand. Right now, which show you are still writing. When you're done, please lower your hand. If you want, you can put a curly bracket for all this what this side 10, 15, 12, like all this what friction. This represent what friction? Static friction. This is static friction. And not the for the diagram, that for the curly bracket I put. Otherwise, this side in the diagram the full in force. Static friction. This 10, 15, 12 represent static friction. Okay, shall we come to the blanks now? Right, done. So we'll complete the blanks here. Right. Now some students they have joined with the wrong name code, so you have to upgrade the name code at the beginning of every month, and you have to join with the same name code. I mean with the current month name code, because I am getting the attendance. Now first one, complete the answer. Frictional force that act on the body as it as it just begins to move. Just begins to move, highlight. Just begins to move is known as what friction? Known as limiting frictional force. Highlight here, known as limiting frictional force. Just begins to move. When the object just begins to move. Just begins to move. So that is the maximum friction between the surface and the object. If you can put an arrow, this limiting frictional force is the maximum value. Maximum friction between the surface and the object. That is the maximum friction. Maximum frictional force between the surface and the object. Between two surfaces. Between two surfaces in contact. Between two surfaces in contact. They should contact with each other to have the friction. Maximum value important. That is the maximum friction. Frictional force cannot be increased beyond this value. It depends on the nature of the surface. Right. So come to the next blank. When the applied force gradually increase, frictional force acting on the body also increases. Right here, frictional force. Actually, that is what friction is. Static friction. Frictional force acting on the body also increases. That is called static friction. If you only write here within where, but friction, this frictional force also increases. When the force applied force gradually increase, frictional force also increase. That frictional force is known as what? This is called what friction? Static friction. Static friction. Within bracket, if you only write here, static friction. Right. But static frictional force can increase only up to a certain maximum value. I told you, frictional force cannot increase continuously with the your pulling force. Again, I repeat, frictional force cannot increase continuously with the pulling force. There's a limit it can increase. Beyond that limit, it cannot increase further. So I will underline that. That's a bit important. Frictional force can increase only up to a certain maximum value. That maximum friction is known as what friction? This maximum frictional force is known as what friction? This maximum friction is known as limiting frictional force. known as limiting frictional force. Complete the blank. Limiting frictional force. It's known as limiting frictional force. I'll highlight the answer. So this is called limiting frictional. Complete the blank. Known as limiting frictional force. Please raise the hand those who are still writing. Okay, when you're done, please lower your hand. So now we discuss out of the 3 types of friction, 2 types. What are the 2 types? First I discuss static friction. Then I discuss limiting frictional force. So which one increases gradually? The static friction. Until the object moves, the static friction is increasing with your pulling force. Until the object begins to move, when you are pulling the cupboard, frictional force also increases backwards. That is called what friction? The static friction. And when you keep on increasing the pulling force, the frictional force reach to a maximum value. It will reach to a maximum value. That maximum value reach known as limiting frictional force. Now still what the object is not moving. Now the object, when it reaches to the limiting frictional force, the object is about to move. Right? About to move. About to move. Just begins to move means what? About to move. If you want, I'll put a curl bracket here. Just begins to move means what? About to move. About to move. About to move. So that at that time, the maximum friction known as what friction? Limiting frictional force. Limiting frictional force. Done. Anyone still copy down? Shall I erase the screen? Anyone still copy down? Shall I erase the screen? Right, I'll erase. Then next one, dynamic. So the 3rd type. So what are the 3 types of friction? First I told you what, okay, I'll quickly summarize. First I told what friction? Static friction. Then I told what friction? Limiting friction. And 3rd one is now we are going to discuss dynamic friction. So this first static friction, then we discuss limited friction. Now we are going to discuss dynamic friction. So static friction means we pull but the object is not moving because of the friction. That is called static friction. When it's about to move, when it just begins to move, the frictional force acting against the motion known as limiting frictional force. Now the object is moving. Now it is moving. When it is moving also friction is there. When it is moving also friction is there. Sometimes what happen, maybe the vehicle or the various moving parts of the engines, vehicle, so they are worn out due to the friction. They are worn out due to the friction. Imagine you have the flow, certain areas in your, maybe in your house, you can observe after the class. So you have the tiles on the floor, tiles. So maybe your doorstep, you can observe the tile, the surface. Sometimes it's worn out, it's become dull more than the other areas. Or the place you stand on the tile in the bathroom, so sometimes it's like bit worn out more than the other place. That is due to the friction. Imagine in a vehicle tire, if there's not enough air, inside the tire. Sometimes what happen, vehicle it's like it's getting worn out in different patterns. Sometimes the corners worn out than the middle. Sometimes the middle worn out than the corner. So if you have pumped more air, the middle is worn out much faster than the corners of the tire. Sometimes if you don't pump, if the tire pressure is less than the recommended value, sometimes the corners of the tires are worn out. Sometimes wheel balancing, wheel alignment, all those also matters. But anyway, you can have an idea whether you are pumping enough air. Right now, dynamic friction, sometimes we call it kinetic friction or moving friction. If you want, you can put a curly slash, right? This dynamic friction is also known as sometimes moving or kinetic friction, sometimes kinetic or dynamic friction or moving friction, kinetic friction, or sometimes we call it moving friction. So frictional force acting on the body or the object after the body starts to move. Underline or highlight after the body starts to move. After the body starts to move. The friction is known as what friction? After the body starts to move. It is known as what? Dynamic friction. I think this blank no need. You can omit this blank. This blank no need. Comma, it's known as, it is known, or it is known as, you can put a comma, right? It is known as dynamic frictional force. It is known as dynamic frictional force. Right. Then dynamic frictional force is what? Less than dynamic frictional force is less than, it is slightly less than the static frictional force. Dynamic frictional force is actually constant, it's not moving, it's constant. Dynamic frictional force is constant and it is slightly less than, it is not increasing like the static frictional force. Dynamic, for the same surface, dynamic frictional force is constant and it is slightly less than the static frictional force. Don't worry, I'll summarize all three again. So what are the three types of friction? Static, limited and dynamic. Now the object is moving between the friction experience. I have given again a point. Friction experienced by what? Moving object. Underline here, moving object. Any friction experienced by moving object between the surfaces of the moving object or objects in motion, that is called what friction? Dynamic friction. Dynamic friction. Dynamic friction. So maybe I have got two diagrams here. Moving force, so the maybe cogwheel set vehicle, bicycle, motorcycle, three-wheeler or lorry bus. So there are various moving parts. Engine also, it's moving also between the, that's why we put lubricants. Engine oil. Engine oil or the lubricants. Because of these moving parts of the engine are worn out easily if you don't pump enough engine oil or if you don't replace it on time. Otherwise the engine can get overheated. Engine can get overheated and it can damage the engine. And sometimes you might have heard about this, they put a coolant also. Coolant. Why coolant? Or sometimes ancient time instead of coolant they put water. Because of the friction, the parts of the engine getting heated up. When they are rubbing against each other, they get overheated and can cause severe damage to the engine if you don't have enough coolant as well as engine oil. Coolant actually they use for the radiator, the AC, and the engine oil for the engine. Done? So we are going to compare now. We are going to summarize all three now. Static, limiting and dynamic frictional force. I think at the end of this lesson, I think I have given some questions also from recent past papers and practice questions also from friction lesson. This is not a very lengthy lesson, remember. Right, unit 4 and 5 not very lengthy. Unit 3 chemistry is bit lengthy. Unit 6 also it's not lengthy, we can complete. Now since you have done, can be well prepared before the term test. Since you have done all this beforehand, like actually the government schools, before the first term test, you should be able to get good marks. Since there's only one more lesson to complete for the first term. But anyway, we will be doing the rest also. Otherwise, we won't be able to complete. Because our main target is not the term test, actually the oral exam, 2023 oral exam. Right. Anyone still copy now? Shall I raise this? Done. Right. Now look at this graph. Here you can see the y-axis friction in Newton. You put Newton here. Force applied also in Newton. Now you can see there are three parts here, the graph. So when the force is increasing, the friction also increasing. It's like a velocity time graph. So this part, the first part, the curly bracket, you can write what friction. What is this friction? When the force increase, friction also increase. When the force increase to 10 Newton, friction also increase up to 10 Newton. When you increase the force like that, you can see with the increase of the pulling force, the friction also has increased. What is this friction called? Any volunteers? Who can tell me the answer? What is this called? What is this friction called? With the increasing of the pulling force, friction also increasing. Yes? What is this friction called? Yes, Pathika?
So static frictional force.
Yeah, very good. That is static frictional force. Very good. So right in front of this curly bracket, right, everyone. That is called the static friction. So here the object is at rest. Oh? So here the object is at rest. If you want to write below this, at rest, not moving. It is not moving. Not moving means it is at rest. Or you can write at rest. At rest. So what is this called? Static frictional force. So write about this static frictional force. Or you can write just static friction. We'll write just static friction. Now next one is what? Who can tell me the next arrow? What is this arrow? The peak here, the maximum value. This is the maximum friction. That is the maximum friction. In this graph, the peak, highest value. Yes, any volunteers? The maximum friction. This point, the friction is maximum. Maximum friction. What is friction called? This maximum friction is known as? Yes? Any volunteers? What about the others? The maximum friction reached between any two surfaces is known as what friction? Friction cannot increase beyond this. In the graph, the peak. If your pulling force, you can increase. X-axis you can increase, but the y-axis, that is the highest value. What is this called? Yes, Pragit?
Limiting friction. Limiting friction.
Yeah, very good. Very good. Yes, that is limiting frictional force. This maximum friction is known as limiting frictional force. So please label that, everyone. Limiting frictional force. If you only write within bracket, what? Begins to move. When the object begins to move, this limiting frictional force is the frictional force when it begins to move. When the object begins to move. So they are the limiting frictional force is what? The maximum friction. It will be the maximum friction. Friction reached to the maximum value. Friction is maximum. Friction is maximum at this point. Friction cannot go beyond that. Friction cannot increase beyond that. So this is limiting frictional force. This is static frictional force. After that, what happened? After that, you can see the next curly bracket. It slightly decrease and is moving. Below this, I will write here, it's moving now. The object is moving. It's moving. What is this friction called? It's moving now. What is friction called? Yes, any volunteers? The last one? It is slightly less than the limiting frictional force. Yes, Sandosha?
Dynamic frictional force.
Yeah, very good. That is dynamic frictional force. Dynamic frictional force is constant. You can see this horizontal line, the same value. Dynamic frictional force is constant, or just write dynamic friction. It is constant and it is less than limiting frictional force. It is less than the limiting frictional force. So it's when the object is moving. Done? If you only can put here 1, 2, 3. What is the first one? Number 1, static friction. Number 2, limited friction. Number 3, dynamic friction. Dynamic friction. Right. Please raise the hand those who are still writing. So these are the 3 types of friction. What are the 3 types of friction? Static friction, limiting friction, and dynamic friction. So out of these 3, which one is the highest value? Limiting frictional force. At which instance this we come across the limiting frictional force? When the object is about to move. When the object begins to move, the maximum friction known as limiting friction. So the third one, dynamic friction, when the object is moving, it is less than the limiting frictional force. Which friction increases gradually with the pulling force? The static friction. Under static friction, the object is at rest. Object is at rest. Why it is at rest? Pulling force become equal to the limiting frictional force. Pulling force become equal to limiting frictional force. Right. This graph is not given in your textbook. Not given in the textbook. Once in the O-level paper, new syllabus paper, they ask this. Not given in the textbook, but it's very, very important. Very important. I think I have given that and at the end of this theory tutor, I have given that question, O-level passbook question. Not given in the textbook, but it's very, very important. Once in the oral paper, they ask a essay type question from this. You can put 3 stars for this. Very important. Comparison of all 3. Done? Please raise the hand those who are still writing. Okay, I'll erase this now. Today we can almost finish this. Right. Before we start number 6, let's see the questions. I think I might have given. Yeah. This is the question. Can you see here? This is the question they have given. This is 2018 O level. 2018 O level. They have given this. Can you see the graph here? This is the graph. 2018 O level. Just now we discussed this graph. This is the one they have given. What is 2018 O level essay type question? By what name the frictional force exerted on the block of wood known as when the force X exerted is 3 Newton? 3 Newton. You can tell us this all past papers. When it's 3 Newton, what is friction called? Yes, any volunteers? 3 Newton, 2 Newton. When you apply X force, force applied. Y axis the frictional force. What is this friction called? Part A, what is the answer? Okay, shall we quickly discuss this question? Then you will get an idea. We'll part 3. Yeah, this one. This one we'll discuss quickly. Not everything, like the part the relevant to the friction I'll discuss quickly. Who can give me the answer for the part A now? Look at the graph. Just now we discussed this. The theory I explained. What is the answer for the part A? Any volunteers? What is the answer for the part A? 2018 O level. Question from friction. This is from grade 10. You don't learn friction again in grade 11 anywhere. Yes, what is the answer for this? What about the others? Everyone should be able to raise their hand for this. Until it reach the maximum value, it is what? Until it reach 4 Newton to the peak. Until it reach 4 Newton, what is friction called? What about the others? Only Prageet, Bhatika and Sandosha. Chanul, Hiru, Kishon, Malitma. What is the answer? Rashmina, Pavani, Netuli, Rashmita, Tisavi, Vishwa, Sohana, Rohini. What is the answer? What is the answer for part A? What is this friction called? Just one word. Malitma?
Static friction, of course.
Yeah, very good. Answer is static friction. Answer is static friction. Okay, next one. What is the answer? What is the limiting frictional force exerted on the block of wood indicated on the graph? Who can give me the answer for the part B? Who can give me the answer for the part? Because remember, no point of just copying down the note like a clerk without knowing how to answer the questions. The part A. Part B, what is the answer? Who can tell me the answer? Any volunteers? 4 Newton, the peak of the graph. Look at your theory. Just now what is maximum value called? Limiting frictional force. What is the value? Y-axis. What is the value here? What is the value here? What is the limiting frictional force? What is the maximum value of the friction? Y-axis. Yes, Hero. Afan?
Limiting frictional force.
Rohini? Prageet? Bhatika?
4 Newton.
4 Newton.
4 newtons.
Yeah, 4 Newton. So what is don't write limiting frictional force because it's already the limiting frictional force will be 4 Newton. Answer will be 4 Newton. Answer is 4 Newton. Right, 4 Newton. Part 4, what is the answer? Part 4. Part 4 they ask, it was required to drag the large block of wood along the flat rough surface. Two different methods that can be used to reduce the frictional force. To reduce the frictional, how to reduce friction when you are dragging something on the floor? How can you make it easily slip, like without making much effort? How can you maybe cover door or something, any object, without just lifting, you drag it on the floor, but it's a lot of friction, a lot of resistance. How can you reduce it? Common sense. Yes, Afan? You can apply some oil, or apply some grease. Applying some oil or grease between the two surfaces. They are asking two different methods. Large block of wood you drag on a flat surface. So one method of reducing the friction, you can apply oil or grease on one surface, or you can make the surface smooth using a smooth surface. You can put something, a carpet or something smooth between. Use of a smooth surface, making the surface smooth, or use the smooth. Imagine you can check the large block of wood, which side is more smooth. That side you can use in contact with the ground or the floor. What about part 5? Any volunteers? Part 5. The equation should come to your head. Part 5, who can give me the answer? How to get the answer for the part 5? M is given, mass is given, force is given. What is the equation? How to find the acceleration? How to find the acceleration? Calculate the acceleration. Okay, please raise the hand. Those who can give me the answer with the equation. Question is calculate the acceleration. Now the previous lesson, you have to recall the previous lesson what we have done. Yes? Any volunteers? Part 5 the answer. What is the equation? First tell me the equation and then you can tell the answer. First tell me the equation and then tell me the answer. Only Rohini and Bhatika raised the hand. What about the other students? Newton's laws, Newton's second law, what is the equation? Check the previous theory dude. Unit 4, what is the equation you got from the Newton's second law? There are three variables. Two of them known. The third one only unknown. Then you can find the answer easily. Yes, I'll ask the answer from Bhatika.
Sir, we can find the acceleration by acceleration equals to resultant force over mass.
Very good, Bhatika. What is the answer then? What is the final answer you got? Rohini?
0.5 ms minus 2.
0.5 ms minus 2. Very good. So F over m. Acceleration. This is the formal equation. F equals ma. So what is known here? F is known. F is known given. A also known. Unknown one is only the acceleration. Unknown one is only the acceleration. What is unknown? Acceleration is only unknown. Acceleration is unknown. So unknown one you can find easily. How? A equals, take m into the other side, F over m. So I'll apply the values to the equation now. Acceleration equal, F is what? 100 Newton. What is the mass? 200 kilogram. 200 kilogram. What is the acceleration? The answer now. A equals half. Two zeros cancel. Half means what? 0.5. Half means 0.5 unit ms minus 2. Acceleration is ms minus 2. Please raise the hand those who got the answer before me. At least if you can unmute, please raise the hand. Those who got the answer, 100 divided by 200. F over m. Resultant force divided by mass. You can write the simple equation. Very good. Nearly 10 students raised the hand. Very good. At least I am happy because I know you are actively participating in the lesson. Some students like dormant students. Dormant people. They never respond. Right. Next one, part 6. Last part. Actually, after every theory section, my advice, you should practice at least one standard question from O-level past paper or provincial paper, at least one question under each theory section. Then only you know what type of questions you are getting and what to study, what to remember. Otherwise, you are just like a clerk filling notes. You don't know what to study, what to remember, what type of questions you are getting from that section. You don't know. Therefore, part 6, I'll erase the screen. Part 6, the answer will be the block of wood moved. Okay, let's see whether we can do it now. Okay. Block of wood moved distance 4 meters under the unbalanced force. How much is the effective work done? Actually, work done equal force into the distance travel, right? So 100 into 4 meters, you get, okay, right here, work done is equal, work done equal force into the distance travel. Right, everyone, work done equal force into, effective work done means force into distance, F into D, force into distance. So what is the force here? 100 Newton. What is the distance? 4 meters. Then you get 400 Newton meter. That one I can excuse because we have not done this 18th lesson in our syllabus, grade 10 textbook 18th lesson, that is 400 joules. So that one I gave the answer since we have not done the theory, but all the other parts, so this all what up to part 5, all what from this lesson, friction lesson. Now you can see O-level paper, you are getting questions directly from this lesson. But this first part I will do. I will come to that also later. Then I'll discuss this also. Before I move to the next part, theory, because the most important part here, this. Look at the screen, everyone. This one. Question number 1. Who can give me the answer for the part 1? Hurry up. What is the instrument marked as A? Yes, Badika?
Newton's spring balance.
Yeah, Newton's balance. Very good. Newton balance. Or you can write spring balance, also correct. Or you can write spring balance. The next one. Information taken from the above activities given below. Why doesn't the object move in the first 3 instances? Now here you apply 1 Newton, the reading 1 Newton, but the object is not moving, it's at rest. You apply 2 Newton, then also it's rest. You apply 2.4 Newton, then also it is at rest. Then also it is at rest. Then you apply 2.5, that is the turning point. That is you can highlight that. 2.5 will be the turning point. There the object started to move, begins to move. Here it started to move at this point. That is the maximum value. This is the maximum value. That is the maximum friction between two surfaces. Friction is not increasing beyond that. What is friction? Can you put an arrow towards everyone? Put a curly bracket from right hand side or left hand side. This one put a curly bracket and right. What friction? What friction? Static friction. Why it is not moving? You pull but it's not moving. Due to what friction? Due to static friction. Due to static friction. Now look at this. Now 2.5, that is the maximum friction between the zeros. What is this called? What is this called? This is called what friction? 2.5. What friction? Limiting frictional force. Put an arrow toward this and right. Limiting frictional force. His limiting frictional force. Right. Limiting frictional force. The next one, 2.3. It is moving. Now it is moving. What is that called? What friction? So it's moving. Until it moves, static friction. When it begins to move, about to move, limiting. When it is moving, what is that friction called? What is friction called? Yes? This is called dynamic friction. Very easy. They can ask the question different ways. So like a table like this. This is called what friction? Dynamic friction. Dynamic friction. Those who have got the printout, no need to copy down everything, so you can label this. It's very easy to understand, answer any question after that. Dynamic friction. Frictional force or friction, that's okay. Okay, now we can answer easily all the questions beyond this, below this table. Why doesn't the object move in the first 3 instances? 1 Newton not moving, doesn't move. 2 Newton doesn't move. You apply 2.4 Newton, then also it's not moving. Why? Yes? Due to what? Force applied is equal to what? Force applied is equal to the frictional force. Right? Forces are balanced. Because the forces are balanced, the resultant force is 0. Or there are many ways you can write the answer. Force applied is equal to the frictional force, or the pulling force equal to the frictional force, or the forces are balanced because forces are balanced. Forces are balanced. Or you can write frictional force become equal to the force applied. frictional force is equal to the pulling force, or forces are balanced, or resultant force is zero. Any of this correct? There must be unbalanced force in order to move the object. Forces are balanced now. Pulling force has become equal to the frictional force, or else we can write pulling force has become equal to the frictional force. So that also correct. You can write that answer using your own words. Pulling force has become equal to what? Pulling force is equal to what force? Static friction, or just write frictional force. Therefore the forces are balanced. Unbalanced force is zero. Unbalanced force is zero. Any of this correct? Right. Then next one. Let's move down. What is the write the values of the instances by using the above observation. Limit in frictional force. Write the value. Write the value. Yes. What is the value? You have marked this in your rough paper, so I will direct write the answer now. Who can tell me the answer for the this one part 1? Write the values. Limit in frictional force. What is the value? Who can tell me? I marked that in the graph in this table. Yes. What is that? Who has done this? Malitma? Winnie?
2.5 Newton.
Very good. It's 2.5 Newton. Limit in frictional force will be 2.5 Newton. And dynamic frictional force? Dynamic frictional force, what is that? Who can tell me the answer for the dynamic friction? Yes? Any volunteers? Prageet? Suhana?
0.3
0.3
Newton.
Newton.
2.3 Newton. Very good. 2.3 Newton. Correct. 2.3 Newton. The next one, write a method of reducing friction by applying lubricants, by applying grease, by applying oil. You can write any of them. By making the surface smooth, applying lubricants, or oil, or grease. Or you can write by making the surface smooth. Any of this correct? Any of this correct? That's all right, this question. So this one I wanted to do for homework. Question number 2, the similar one. Similar one, the same table, so similar table I have given. Here also we can see the turning point. Here this maximum friction is 12. If you can mark that is the limiting one. So until that it is what? Static. You can put a curl bracket, so then you can do the rest easily at home. Static. And this is what? 10, 10, 10, 10, 10, no change. After that is dynamic. Can you please mark that? 10, 10, 10 dynamic, 12 is limiting, and this 0369 will be static. This is limiting. Is that clear? Then you can do the rest at home. Okay, that is for homework. Please mark this for homework. Question number 2. First one I have done. After that, this one also, the first part you can do at home. Right. Now let's move back to the factors. Next part, page number 3 top. Factors affecting the limiting frictional force. Right. Factors affecting the limiting. So these practicals are extremely important. Actually, these are experiments of the practicals. Experiments or the practicals, so the activities. It's given in your textbook also. These activities very important. You get structured say compulsory questions mostly from these practicals or the experiment. So nature of the surface, you can see here rough sandpaper, valley cut. You can get this from the hardware shops. Rough sandpaper, right? So you attach the block of wood, the rough surface placed in outside. Rough surface placed in outside. You attach this to the block of wood. You can have the sandpapers with different roughness. Sandpapers with different roughness. When the roughness of the sandpaper increase, reading of the balance or the force required to move the block of wood increase. The force required to move the block of wood increase with the increase of the roughness of the sandpaper. We can use sandpapers with different roughness. Limited frictional force increases with the increasing of the roughness of the sandpaper. So complete the blank here. Complete the blank here. Limited frictional force increases. I'll highlight here. Limited frictional force increases with the increase of the roughness of the sandpaper. Roughness of the surface. So the surface can be a different surface. So I will write in general roughness of the surface. You can put a standard in front of this diagram, right? When using the sandpapers with different roughness, right? When using the sandpapers with different roughness, when using sandpapers with different roughness, what happened? When using sandpapers with different roughness, the force required, the balance of the reading, the reading of the balance when it begins to move also increase, or the force required to move the block of wood also increase. When using the sandpapers with different roughness, the force required to move the object increases with the roughness. Force required to move the block of wood, force required to move the block of wood increases, or you can write reading of the balance increases with the increase of the roughness of the sandpaper. The block of wood required to move the block of wood increases with the roughness of the sandpaper. Force required increase, highlight here, force required highlight, increase highlight, force required highlight, increases highlight with the roughness of the sandpaper, Is that clear? So you have to use sandpapers with different if you can try this. So if in hardware shops you can different numbers, sandpapers with different numbers, 100, 150, 120. So they have different values. So with that the roughness of the sandpaper also increase. Why do we use different roughness, the sandpapers with different roughness? Otherwise you have to have the block of wood with different roughness. So that's very difficult now practically. Then you have to use many different types of blocks with one block very smooth the surface, the other block very rough and moderate roughness. So instead of that, you attach one sandpaper and do it and record the reading of the balance when it begins to move. And again attach the other sandpaper with different roughness and check the reading. Reading means what? Newton balance value when it begins to move. So then you can see the limited frictional force when the object. So what is observed here? What is the observation? Roughness, reading of the balance. You have to record the reading of the balance when the object begins to move. Reading of the what balance? Newton balance. When the object begins to move, record the reading of the balance. When object begins to move, when object just begins to move, reading of the balance. Reading of the balance. You can get this quantitative also, you can measure it. You can find with which sandpaper you get the highest reading. Highest reading of the balance when the sandpaper with the highest roughness. When using the sandpaper with maximum roughness, reading of the balance also become maximum. That means you need to apply more force, more effort to move it. So very good practical. This is given in your textbook. Activity 2, page number 101, textbook. Activity 5.3, activity 5.3, grade 10 textbook. Textbook page 101 they have given. Please pay more attention to these practicals given in the textbook. Activities, because you are getting compulsory questions in the structured C paper level from these activities. So just to understand what are the things required, how to do it, method or the procedure, what observations and what is the conclusion, or what errors could occur during this practical or the activity, like that. The next one, number 2. I'll erase the screen. Normal reaction. Okay, what is the first factor? Nature of the surface. Now, if you only write here, roughness or the smoothness, roughness of the surface. Nature of the surface means roughness of the surface. When the roughness of the surface increase, what happen? When the roughness of the surface increase, frictional force also increase. When the roughness of the surface increase, frictional force also increase. Frictional force increases with the roughness of the surface. That's what I given here. Limited frictional force increases with the roughness of the surface. So here you completed the blank, right? This is roughness. This is we call it nature of the surface. Whether it's a rough surface or a smooth surface. Next one, normal reaction. That is the next factor affecting the frictional force. Look at here. Normal reaction. Normal reaction means this. Look at the screen now. This is 20 Newton. So that is the weight. Look at the screen. Weight will be 20 Newton. Weight. Okay, if you write here, put an arrow. The weight. Imagine if you take here if weight is 20 Newton, what is the mass? So it's 2 kilogram. 2 kilogram. W equals mg. W equals mg. So the weight is 20. M don't know. Into 10. So therefore, how to find m? 20 divided by 2. Then how many kilos? 2 kilos. That's how you find the mass. If you know the weight and the g is constant. Gravitational acceleration of the earth is constant. If you know the value of W and G, you can find m. So 2 kilos. 2 kilos means 20 Newton that is the weight. That is the weight. And what is the reaction now? What is the reaction? Reaction also 20 Newton. Because every reaction has an equal and opposite reaction. Reaction also 20. Therefore, vertically the forces are balanced. Vertically the two forces are balanced. 20 20. Therefore, vertically the resultant force 0. Vertically upwards, vertically up and down, the forces are balanced. Resultant force 0 or unbalanced force 0. Now you apply a force. Now when this begins to move, you record the reading of the balance. When the object begins to move, when it begins to move, you take the reading. When it begins to move, record the reading of the balance. When it means object, when the object begins to move, just begins to move, reading of the what balance? Newton balance. Now what you do? You make it what? 2 kilogram, 2 kilogram. What is the total? 40 kilos. 40 kilos means what? Sorry, 4 kilos. 4 kilos means 40 Newton. How do you know? W equals mg. W equals mg. What is m here? 4 kilos. G is what? 10. Then what is the weight? 40 Newton. That's how you get 40 Newton here. So 40 Newton means like 4 kilos altogether. Now you have additional block of wood. Now what will be the reaction also here? 40 Newton. Vertically the forces are balanced. Now who can guess this one? Will the reading? Obviously common sense. Here the reading will be greater than the first one or less than first one. So here the reading will be greater. No? The reading of the balance will be Newton balance. The reading will be greater. Newton balance reading will be greater than, reading will be greater than the first one. Newton's balance reading will be greater than the first one. Right. Why? When it's become heavier, you need to make, obviously common sense, when the object become heavier, force required also increase. Why? It's frictional force also increase. Frictional force increases with the weight of the object. More weight, more friction. More friction means more force required to move this object forward. So in the second instance, the friction is greater than the first instance. In the second instance, the friction is, in the second figure, the friction is greater than the first one. Why? Because of more weight. So therefore, the second factor that affects the frictional force is what? We call it R is perpendicular reaction. What is R here? R is perpendicular reaction. R will be perpendicular reaction. So with the increase of the value of R, frictional force increases. So complete the blank here. Frictional force, limited frictional force increases. Limited frictional force increases with the increase of the perpendicular reaction. Perpendicular reaction. Perpendicular reaction means R, or sometimes we call it normal reaction. Sometimes we call it normal reaction. Within brackets, right? Normal reaction. Normal reaction. Perpendicular reaction, it is also known as normal reaction. Right. Done? So if you want to write here, when if you I'll summarize this. When m increases, m is mass. When m increases, what happen? Weight increases. When weight increases, what happen? R increases. When R increases, what happen? Friction increase. When the friction increase, what happen? Force required increase. Then what happen? Force required also increases. Force also increasing. Again I'll tell. Number one, m increase. When m increase, W increase. When W increase, R increase. When R increase, friction increase. When the friction increase, force required also increasing. When the mass is double, the weight also double. No? So all this, if you only write in your short notebook, increasing means arrowhead upwards. It's up. So instead of 2 kilos, 4 kilos. When 4 kilos, weight become 20 to 40. When the weight increase, R increase. When the R increase, frictional force increase. When the frictional force increase, force required to move this object also increasing. So what are the two factors affecting the frictional force now? Number one, nature of the surface. Rough surface, high friction, common sense. Smooth surface, low friction. Smooth surface, low friction. What is the second factor that affects the frictional force? Normal reaction. Normal reaction or perpendicular reaction, that is called R. Look at the diagram. R depends on W. W depends on mass. And so the friction depends on the R. R depends on W. W depends on mass. So therefore, when the object becomes heavier, more friction. Is that good or bad? Good. Example, I'll give one of the best example. If a motorcycle is very light in weight, while you are driving very fast, if you apply brakes, what happens? It becomes very unsteady. So unbalanced. If the vehicle is heavier, it will not roll or it will not slip easily. The other example, I'll give one of the best example for this. When a vehicle gets stuck in mud, you might have experienced this sometime. Muddy road or maybe beach or in the sand. If you are driving a vehicle, sometimes what happens in the vehicle, it gets stuck in mud. So in mud, the vehicles get stuck in mud. So now the driver is racing the engine to the higher speed. Driver is racing the engine to the higher speed. So this rear wheel is stuck in mud. So getting rotated at the same place, but the vehicle is not moving forward. Driver is racing the engine. The rear wheel is moving very fast at the same place without moving the vehicle forward. So what you are doing now, there are many options for this. Now rear wheel stuck in mud, get stuck in mud, get submerged. Now you want to get the vehicle out of mud. So one method, you have to increase the friction. So how to do this? Increase the friction between the road and the tire. How to do that? How to increase the friction? One method, you can change the nature of the surface. Friction has to be increased. Then it will not slip. Now driver is racing the engine. The wheels are rotating at the same place. Look at the screen. You can see the diagram, right? So then to overcome this problem, friction has to be increased. To increase the friction, one method, you have to change the nature of the surface. You can put some gravel or sand or whatever the solid objects or the stones you can put. That is to make the surface rough. Second one, to increase the friction, you can increase the perpendicular reaction or normal reaction or perpendicular reaction. When the normal reaction or the perpendicular reaction increase, it increases with the friction. The friction increases with the normal reaction. Normal reaction depends on the weight. So there are two methods. Friction you can increase by changing the nature of the surface, or number one, nature of the surface. Surface you have to change. Muddy one, changing the surface is very difficult. So or else you can increase the reaction. What are the two methods? To get higher friction, either the normal reaction or the weight of the object should be increased, or surface of the nature of the surface should be changed. So how to increase the reaction? You have to increase the mass of the vehicle. How to increase the mass? You can ask. So imagine now this kind of situation, many people are watching like a movie. They are enjoying. The vehicle has got stuck in mud or lorry or bus. Now the driver is making, the people inside the bus making much effort to get this out of mud. So what happened now? The audience, the people, those who are around this truck or the lorry or bus, you can ask them to get into the vehicle. Come, don't just watch out from outside. Come inside. And then what happened? Now what happens? Weight of the vehicle increase. When the weight increase, the reaction increase. When the reaction increase, friction increase, and you can get the vehicle out of mud. That's why the heavy vehicle, like if the vehicle is light in weight, it's very dangerous. So motorcycle very light in weight, so you should not drive very fast, so it will go out of the road. The friction is low, or loaded lorry bus, so there's more friction. So by experience you know this, right? Now if I quickly summarize today what we discussed, if I again summarize, at the beginning I told what is frictional force. I told frictional force is it's a force and it is measured in Newton and it is a vector quantity. And I told when the object is placed on a horizontal surface, no friction. But if you are keeping the object on a flat surface, or if we are applying a force on the object at rest, then the friction will be there. In both these, friction will be there. And then I told there are three types of friction. Number one is static friction. When the object, until the object is moving, until the object begins to move, it is called known as static friction. The static friction, no definite value, it will increase the force applied. Then second one, limited frictional force. Limited frictional force is the highest value out of these three types of friction. Limited frictional force is the force, or that's the one which reaches to the maximum value between any two surface, and that is the instance where the object just begins to move. Limited frictional force. And then I told dynamic friction is the friction that experienced by moving objects. So due to their motion, any moving object experiences dynamic friction. So this is the graphical representation. Limited frictional force at the peak, then the middle arrow, and the other two, this one is static friction. Object is at rest even though force is applied, that is static. This is dynamic, and this middle one is limiting frictional force. So out of these three, highest value is limiting frictional force. Limiting friction force is highest value. Then after that I discuss about factors affecting the friction. You can change the friction if you want, as well as you can increase the friction. How? By changing one of these. Number one, you can change the nature of the surface, smooth or rough. Second one, normal reaction or perpendicular reaction. That a reaction depends on weight and weight depends on mass. Yeah. Right. Okay, then so that's next day I gave I think a question also for homework, end of this tude, and next day we can complete this number 7. Yeah, and then on 2 pages. Yeah, we can finish this lesson next week, and most probably I'm going to start the next week the 6th lesson also. 6th lesson also I'll be starting next week. And from next month you will be having the paper class Saturday evening 6 to 8, every Saturday evening 6 to 8, permanent online paper class. I'll send a message to your remind to your group also. And new students also can join with the paper class if they have missed the first few lessons. Right. Now we'll stop for today. It's almost 8 o'clock, so this one I'll do next week. Right. So for today, good night and God bless you.